Exploring Density, Conservation, and Rotation in Science, a fun-minute explanation. Please subscribe to my channel. Welcome to Exploring Density, Conservation, and Rotation in Science, a fun-minute explanation. In this brief overview, we'll dive into three fascinating concepts in science: density, conservation, and rotation. 1. Density. Density is a measure of how much mass is packed into a given volume. 1. Imagine two objects of the same size, but one feels much heavier. 1. That's because the heavier object has a higher density. 1. It's like comparing a rock and a sponge. The rock feels heavier because it has more mass in the same amount of space. Density is calculated by dividing an object's mass by its volume. The formula is density equals mass, volume. Water is often used as a reference point for density, and its density is approximately 1 gram per cc, gram per cc. Objects with a density greater than 1 gram per cc will sink in water, while those with a density less than 1 gram per cc will float. 1. Conservation. Conservation laws are fundamental principles in science that state certain quantities remain constant in a closed system, even as other things change. 1. The three main conservation laws are: A. Law of conservation of mass. Matter cannot be created or destroyed in a chemical reaction. 1. It simply changes form. 1. B. Law of conservation of energy. Energy cannot be created or destroyed. It can only change from one form to another. 1. C. Law of conservation of angular momentum. Angular momentum, which depends on an object's mass, shape, and rotation speed, remains constant unless acted upon by an external torque. Conservation laws help scientists understand and predict various phenomena, from chemical reactions to the behavior of celestial objects. 1. Rotation. Rotation is the act of spinning or turning around an axis. 1. Think of the Earth rotating on its axis, causing day and night. 1. Angular momentum, which we discussed earlier, plays a vital role in rotational motion. 1. When an object's angular momentum changes, its rotation speed or direction can also change. 1. This is why you may have noticed ice skaters spinning faster when they pull their arms closer to their bodies, conserving their angular momentum. Rotation is an essential concept in many areas of science, from understanding celestial bodies like planets and stars to designing machinery and vehicles. In summary, density describes how much mass is packed into a given space. Conservation laws explain the preservation of certain quantities in nature, and rotation involves spinning or turning around an axis. These concepts offer exciting insights into the natural world and contribute to numerous scientific discoveries and innovations. So, the next time you see an object floating, think about its density. When witnessing a spinning object, consider its conservation of angular momentum. Science is truly a fascinating journey of exploration. Thanks for watching.